Imagine a universe so vast, so mysterious, that it sends messengers from distant stars to whisper secrets of the cosmos. In 2017, humanity received such a visitor, an object so strange, so alien, that it defied everything we thought we knew about the universe. This was no ordinary space rock. It was Oumuamua, the first confirmed interstellar object to grace our solar system, a cosmic wanderer from beyond the stars. Its arrival sparked a frenzy of curiosity, debate, and wonder. Was it a comet, an asteroid, or something far more extraordinary? Now, in 2025, the saga continues as another enigmatic traveler, 3I/ATLAS, approaches our sun, promising to deepen the mystery and challenge our understanding of the cosmos. Buckle up, because this journey through the stars is about to get wild, and we're diving deep into the unknown to uncover the truth. Stick with us until the end, because the universe has more surprises in store than you can imagine. Let's rewind to October 2017, when a faint blip of light caught the attention of astronomers at the Pan-STARRS 1 telescope in Hawaii. At first, they thought it was just another comet or asteroid drifting through our solar system. But as they peered closer, they realized this was no ordinary visitor. Named Oumuamua, meaning scout or first distant messenger in Hawaiian, this object was moving at a staggering 87 kilometers per second, far too fast to be bound by the sun's gravity. It was on a hyperbolic trajectory, a cosmic slingshot that screamed one thing: this thing wasn't from around here. Oumuamua had already made its closest approach to the sun, swinging inside Mercury's orbit, and was speeding out of the solar system by the time we spotted it. Its velocity was mind-boggling. To escape the sun's gravitational pull from Earth's distance, an object needs to reach an escape velocity of about 42 kilometers per second. Oumuamua was clocking more than double that speed, suggesting it had traveled from another star system, untethered by our sun's influence. But what made it truly bizarre wasn't just its speed, it was how it moved. As it zipped past the sun, Oumuamua didn't slow down as expected. Instead, it accelerated. According to the laws of physics, a rocky object passing close to a massive gravitational force like the sun should decelerate. Yet, Oumuamua defied this, hinting at some internal force propelling it forward. This wasn't the behavior of a typical asteroid or comet. It was something else entirely. Then there was its appearance. Most asteroids are roughly spherical and dimly reflective, but Oumuamua was different. Its light pulsed every 7 hours, swinging from bright to dim and back again, suggesting it was either long and cigar-shaped or flat and saucer-like, tumbling end over end through space. Its surface was highly reflective, unlike the dull, rocky asteroids we're used to. This led astronomers to estimate it was about 100 to 400 meters long, but only a fraction of that in width, an unprecedented shape for a natural object. The combination of its speed, acceleration, and bizarre shape sparked a question that sent shivers down spines. Could Oumuamua be an alien spacecraft? Tracing Oumuamua's path backward, astronomers found it came from the direction of Vega, the brightest star in the constellation Lyra. Vega isn't just any star, it's one of the most studied objects in the night sky, once serving as Earth's North Star 14,000 years ago, and set to reclaim that title around the year 14,000 CE due to the slow wobble of Earth's axis. This cosmic coincidence adds a layer of mystique, but there's no evidence Oumuamua originated from Vega's system. It simply came from that direction. Interestingly, our solar system is also moving toward the constellation Lyra, meaning Oumuamua and our sun were on a near-collision course. It passed within 24 million kilometers of Earth, close in cosmic terms, but still 60 times the distance to the moon. By the time we spotted it, it was already on its way out, leaving us with more questions than answers. Its fleeting visit didn't give us much time to study it, and its incredible speed made chasing it with a probe impossible. Chemical rockets couldn't catch up, and even a complex gravity assist maneuver using Jupiter and the Sun was deemed impractical. But Oumuamua wasn't the end of the story, it was just the beginning. In 2019, the cosmos threw us another curveball. An amateur astronomer named Gennady Borisov discovered a second interstellar object, aptly named Borisov. Like Oumuamua, it followed a hyperbolic trajectory, too fast to be captured by the sun's gravity. It came from the direction of the constellation Cassiopeia, also in the northern sky, and was unmistakably a comet. Unlike Oumuamua, Borisov had a visible coma, a fuzzy halo of gas and dust, and a distinct tail, classic signs of a comet sublimating as it neared the sun. Borisov's composition resembled comets from our own solar system, made of frozen water, ammonia, and other volatiles. It was exciting but not as bizarre as Oumuamua. Still, its arrival was significant. For centuries, we'd seen no interstellar objects, and now we had two in just 2 years. Was this a cosmic coincidence, or were we finally noticing something that had been happening all along? Fast forward to July 1st, 2025, when the Asteroid Terrestrial Impact Last Alert System, ATLAS, detected a new intruder, 3I/Atlas, the third confirmed interstellar object. Unlike its predecessors, we caught this one early, as it was still 4.5 astronomical units from the Sun, roughly the distance of Jupiter's orbit. This gave us a rare opportunity to observe it as it approached, rather than catching it on its way out. 3I/ATLAS is a beast. Initial observations suggest it's a comet with a coma spanning up to 20 kilometers, but its solid nucleus could be as large as 11 kilometers, 10 times the size of Oumuamua and 5 times that of Borisov. It's moving at a blistering pace, faster than Oumuamua, and its trajectory is unlike anything we've seen. While Oumuamua and Borisov came head-on from the northern sky, 3I/ATLAS is slicing through the solar system from the side, originating from the Milky Way's thick disk, a region of older, less dense stars above and below the galaxy's thin disk, where our sun resides. The thick disk is a cosmic time capsule, home to objects that could be over 7 billion years old, older than our solar system itself. If 3I/ATLAS hails from this region, it's an ancient relic, carrying clues about the early universe. Its trajectory will take it on a grand tour of the inner solar system, passing within 28 million kilometers of Mars, 97 million kilometers of Venus, and just 53 million kilometers of Jupiter. Curiously, it will miss Earth entirely, staying on the opposite side of the Sun during its closest approach in late 2025. Our telescopes will lose sight of it in October, only catching it again in December as it exits the solar system. This trajectory has sparked wild speculation. Is it a coincidence that 3I/ATLAS seems to be sightseeing our planetary neighbors while avoiding Earth? Some might argue it's the deliberate path of an alien probe, gathering data while staying just out of reach. But let's not get carried away. There's a lot we can learn from this object without invoking extraterrestrial architects. The peculiar behavior of Oumuamua and 3I/ATLAS begs the question, what are these things? Let's start with Oumuamua. Its lack of a visible coma or tail ruled out a typical comet, but its acceleration suggested some form of outgassing. One hypothesis is that it's a comet made of exotic materials, like nitrogen ice. Picture a dwarf planet like Pluto covered in highly reflective nitrogen ice, shattered by a cosmic collision. A fragment of this frozen nitrogen could be flung into interstellar space, eventually reaching our solar system. As it nears the sun, the nitrogen sublimates into invisible gas, acting like a thruster without producing a visible tail or coma. This could explain Oumuamua's acceleration and reflective surface. 3I/ATLAS, on the other hand, is clearly a comet, with a visible coma and likely a tail as it approaches the sun. Its massive size and ancient origins make it a treasure trove of information about the early galaxy. But its trajectory and size raise new questions. Why are these interstellar visitors getting bigger? Are we just getting better at spotting them, or is something else at play? To understand these objects, we need to dive into the physics of the cosmos. Everything in our solar system, planets, asteroids, comets, is bound by the sun's gravity, orbiting in predictable paths. Interstellar objects, however, follow hyperbolic trajectories, meaning they're moving too fast to be captured. This is because they originate outside our solar system, likely ejected from their home systems by gravitational interactions, such as a close encounter with a massive planet or star. Comets accelerate near the sun due to sublimation, where ice turns directly into gas, releasing dust and creating a coma and tail. This outgassing acts like a rocket thruster, altering the comet's trajectory. Oumuamua's acceleration, without visible outgassing, suggests it could be made of a gas like nitrogen, which is invisible when sublimated. 3I/ATLAS, with its visible coma, fits the comet mold more closely, but its size and trajectory make it a unique specimen. The Milky Way's structure also plays a role. Our solar system lies in the thin disk, a dense plain of stars and planets. The thick disk, where 3I/ATLAS may originate, is less populated and contains older objects, remnants of the galaxy's formative years. These regions are like cosmic archives, preserving clues about the universe's history. By studying these interstellar visitors, we're peering into the past, piecing together how stars, planets, and perhaps even life came to be. Let's address the elephant in the room. Could these objects be alien technology? The idea isn't as far-fetched as it sounds. Oumuamua's unusual shape, reflective surface, and unexplained acceleration led some scientists, like Harvard's Avi Loeb, to propose it could be an artificial object, perhaps a light sail or probe sent by an advanced civilization. 3I/ATLAS's strategic trajectory, avoiding Earth while passing close to other planets, adds fuel to the speculation. But extraordinary claims require extraordinary evidence, and so far, we have none. The alien hypothesis is compelling because it taps into our deepest curiosity about the universe. Are we alone? Could an advanced civilization have sent a probe to study us? The lack of radio signals, deliberate maneuvers, or other hallmarks of technology makes natural explanations more likely. Still, the possibility keeps us wondering, and that's what drives science forward, asking questions, even the wild ones. The arrival of 3I/ATLAS isn't just a scientific milestone, it's a call to action for all of us. These interstellar visitors remind us that the universe is a vast, untamed frontier, full of mysteries waiting to be explored. You don't need a PhD to join the adventure. Download a stargazing app, point your phone at the sky, and start tracking the stars. Visit a planetarium, attend a public lecture, or follow real-time updates from observatories like Atlas or NASA. The cosmos is open to everyone, and every question you ask brings you closer to its secrets. Share this journey with friends, spark discussions, and let the wonder of the unknown ignite your curiosity. The universe is speaking. Are you listening? As 3I/ATLAS races toward the sun, it's a reminder that the universe doesn't wait for us. It keeps moving, and so must we. The next few months will be critical. Will we uncover new clues about its composition? Could we redirect a spacecraft for a closer look? Or will 3I/ATLAS slip away, leaving us with more questions than answers? Just like Oumuamua, the answers lie in our ability to keep pushing, to keep observing, and to keep dreaming. The next interstellar visitor could be even stranger, even more revealing. So, stay curious, stay engaged, and keep your eyes on the skies. The universe is full of stories, and we're just beginning to read them. You might be wondering, why should I care about a chunk of ice or rock from another star? Because these objects are more than just celestial curiosities. They're messengers from the universe's past, carrying clues about how it all began. They challenge our assumptions, push the boundaries of science, and remind us how small we are in the grand scheme of things. Yet, they also show how far we've come, using technology to peer into the void and ask questions our ancestors could only dream of. The story of Oumuamua, Borisov, and 3I/ATLAS is a reminder that the universe is full of surprises. Each new discovery brings us closer to understanding our place in the cosmos. Are we alone? How did the galaxy form? What else is out there, waiting to be found? These questions drive us to keep looking, keep exploring, and keep wondering. The discovery of these interstellar objects highlights the incredible advancements in our observational technology. Telescopes like Pan-STARRS 1 and Atlas are revolutionizing how we monitor the skies, scanning vast regions with unprecedented precision. These systems use automated algorithms to detect faint, fast-moving objects that would have been missed a decade ago. The James Webb Space Telescope, launched in 2021, offers infrared capabilities that could reveal the chemical makeup of 3I/Atlas's coma, giving us clues about its origins. Meanwhile, citizen scientists and amateur astronomers, like Gennady Borisov, are proving that anyone with a telescope and passion can contribute to cosmic discoveries. This technological leap is turning the night sky into an open book, and we're reading it faster than ever before. Beyond science, these interstellar visitors are sparking a cultural phenomenon. Oumuamua captured the public's imagination, inspiring books, documentaries, and even sci-fi novels. Its enigmatic nature fueled discussions on social media, with hashtags trending worldwide as people debated its origins. 3. I/ATLAS is poised to do the same, igniting curiosity among students, artists, and dreamers. Schools are incorporating these discoveries into curricula, encouraging kids to explore astronomy and physics. This isn't just about data, it's about inspiring a new generation to look up and wonder. By engaging with these cosmic mysteries, we're fostering a sense of global unity, reminding humanity that we're all stargazers, connected by the same sky. These interstellar objects push us to ask profound questions about existence. If 3I over ATLAS is a 7 billion-year-old relic, what stories does it carry from the early universe? Could it hold clues to the conditions that led to life on Earth? The possibility of alien technology, however remote, forces us to confront our assumptions about intelligence and our role in the cosmos. Are we a fleeting spark in the galaxy, or part of a larger tapestry of life? These visitors remind us that the universe is indifferent yet endlessly fascinating, urging us to explore not just the stars, but our own purpose. As we study these objects, we're not just seeking answers, we're redefining what it means to be human. You might be wondering, why should I care about a chunk of ice or rock from another star? Because these objects are more than just celestial curiosities. They're messengers from the universe's past, carrying clues about how it all began. They challenge our assumptions, push the boundaries of science, and remind us how small we are in the grand scheme of things. Yet, they also show how far we've come, using technology to peer into the void and ask questions our ancestors could only dream of. The story of Oumuamua, Borisov, and 3I/ATLAS is a reminder that the universe is full of surprises. Each new discovery brings us closer to understanding our place in the cosmos. Are we alone? How did the galaxy form? What else is out there waiting to be found? These questions drive us to keep looking, keep exploring, and keep wondering. As 3I/ATLAS approaches, the scientific community is buzzing with excitement. Every observation brings new data,